Hey guys, welcome back aboard Sasa. We're in the interior salon of the boat, and this is the brains of our electrical system. So one of the biggest projects we wanted to do this winter was completely revamp our DC and AC electrical system. We had an older system with AGM batteries. So over on this side, we have the back of our DC electrical panel. And it's a large panel with tons of switches for all of our DC components. As you can see, it's a bit of an old switchboard and a lot of the columns aren't even used. So there's room to expand and add more appliances. Our boat, like many other boats, has some components that are 24 volts and some components that were easier to source as 12 volts. But the panel never denoted what was what. So one of the first investigatory things we had to do was pull open the back of this panel and figure out what was what. So when I started looking at it, these are all a DC circuit, so you can see power coming in on a big large cable, and then it's branched over to the back of each circuit panel. And then when we get to the very far row, we actually saw a different cable coming in, and it was separated from the rest. So once I identified that and looked at what those systems were, I then discovered that this far row and this far column was 12 volt only. And so one of the biggest thing a boat designer can do is label all their wires. And so our wires were not labeled. So I've been going around and making our own labels to stay on the wires so we know what's what in the backbone of our system. So right now what we have is our first 4 columns for our 24 volt system, and the far left column is our 12 volt system. Once we put everything back together, I'm going to label it accordingly so you can see from the outside where we have open 12 volt circuits if we needed to add any more components, and which ones are 24. With the DC system, both 24 and 12 can all share a central DC negative bus. And so the latest ABYC standards switched from the negative DC wire being black to yellow. So if you have an older boat, you can see this has a mix of new wires and old wires. So the yellow is definitely wires that have been added somewhat more recent, and then the black are some of our later legacy wires. So this negative is for all the small switches of the DC bus, and it goes to our main overall boat negative bus, which is down closer to the batteries underneath the floorboard. Some other really cool components of this panel is that we had these Bass product different meters that could tell us what the AC volts coming in was, what the AC frequency was, and then our shore power system currently is set up to be 120 and 240, 50 amps coming in. So I'm able to have 2 different lines of 120 volt AC lines. And so this can tell you how many amps each line is pulling. And then we also had indicators for the house voltage, the engine voltage, solar inputs, and hydro generation. One of these solar used to be for wind. We removed an old wind generator off the boat, and we're gonna just replace everything with solar. And the hydro we also don't have installed on the boat, but it's there in case we ever do want to install that. So this was really cool to just diagnose what we currently have and help redesign with how do we go forward and see how these change. Like this indicator, the house voltage for a lithium ion setup, the voltage is not as important as the battery capacity, and the whole lithium bank is going to be monitored via the bank monitoring system, and it's going to all talk to a servo and have its own touch screen. So here you can see I've already removed some old products too. This was the old control box for our Magnum inverter, and I've already removed that, and that was an older generation inverter. It worked well to create DC to 120 AC. It was also a charger, so it was an inverter charger unit, but it had some intricacies that was older technology that no longer applies when we use the Victron Multi-Plus setup. So I'll get into a little bit more of that later when I talk about the neutral bus bars. But we'll replace this, we'll keep the same location, and this is where our Victron GX screen is going to live that controls all of our Victron products and monitors through the BMS and the Victron Servo, monitors the capacity of our batteries, what is coming in, what's going out, and the whole system. So this would be the new location for that display. Okay, now over here we move to the AC side. So over here, this is our old AC bus. So this was the 120 240 volts AC panel, and we had to really figure out what was going on behind this panel. So it had some cool components, which was the shore power and generator power both come into this panel, and then it has an isolation switch allowing you to only switch one on at a time. You want to make sure you only have one incoming AC power source. They're never both on at one time. So the things that I had to figure out about this was on the back of the switch panel, the shore power was 120 240. So what that means is that it had two hot lines coming in with a neutral and a ground. So this black cable brought in 120 volts AC, and this red cable also brought in 120 volts AC. And that's pretty typical for an AC big boat system. And what it really allowed is on shore power, we had two different lines carrying 50 amps, that this whole column was separate from this whole column. And the reason that was done mainly is to power our air conditioners. We have 4 air conditioners on the boat and a hot water heater. So this allowed tons of power coming into the boat to power those individual air conditioners. And while diagnosing issues over the summer, we saw that when we plugged into some faulty shore power, we found out that sometimes only air conditioners on line 1 would work and no line 2 would work when we were plugged into a proper 120/240 receptacle. And so we had the port air conditioner would work and the salon would work, but the aft and the starboard wouldn't work. And now I understand that more. These labels weren't here. There were no labels saying which one was line 1 and which one was line 2. And so I added that as I'm figuring this out. But that explains a lot more on what was going on with our system. And when we were plugged into shore power, why only some of the ACs were working is because we were only getting one hot line instead of 2. The way this panel is also set up is these lower switches are the only inverter powered switches. So when the inverter's running and no generator, no shore power, the only thing we could power was our outlets for the galley and cabin, a microwave, which we removed and replaced with our coffee maker. And then there was an old run to the television in the back room that we never ran. So with the old setup, I only had these 6 breakers to run off inverter power. Everything else from line 1 or line 2 had to have the generator running or had to have shore power connected. Our new setup is going to completely change this, make this entire panel able to run off the inverter, and then I'm going to use some of these spaces to create a 240 volt breakers. So it took a lot of time just to diagnose what we currently have, how's it set up, and how are we going to reuse similar locations and panels for our new design. All of that would have been simplified if everything just would have been labeled. So I've gone back and added a lot more labeling. I've labeled where the shore power comes in. I've labeled the generator neutral. It's important to note, since we had 120/240 coming in on the shore power that required 2 hot lines, it was a 3-pole breaker to turn on the shore power. Then to match it, the generator also had a 3-pole breaker, but only 2 of these were actually active because the generator just runs on 120. So the generator just brings in one hot line and one neutral. And so they had a jumper to create all 3 switches live, but 2 were really only doing anything. These little donuts are also pretty cool, and I labeled these. These donuts are what feed the sensors on the main panel. And so these donuts measure amps running through each hot line. And so it's similar to using a voltmeter that clamps around a wire. It can read amps running through the wire without actually touching the conductors. And so this reads the amperage going to line 1, this reads the amperage going to line 2, and then can display it on our other panel telling us how much power we're using. Alright, there's some more cool stuff. So the easiest way to see if a boat was wired professionally, in my opinion, is if it has labels. Ours did not have any labels. It doesn't mean it wasn't professional, it just means that it's harder to the next owner. So I started adding some labels in here. The next is how pretty the wiring is. And so this had all kinds of cable ties I've already removed. That's step 1 with trying to do any electrical job, is removing hundreds of cable ties. So this is pretty well organized in here. A couple things that are going on behind this AC electrical panel that are interesting is the separation of a shore neutral bus and an inverter neutral bus. And so this was required with our old Magnum inverter charger, is that anything coming out of the inverter had to have a separate neutral bus that was completely isolated from any of the shore power equipment. And this whole design is getting changed with new Victron Multiplus inverter technology, because inside the Multiplus, it's the initial feed for all of our AC power systems. So everything's going to feed the Multiplus first, and then the Multiplus is then going to feed the panel, and it has internal neutral switching, and so it identifies whether the neutral ground bond between the white and green wire only happens at the source of power, and only one source of power at a time. So the only time the neutral and ground are bonded is at the source of the generator, and for our new design is going to be at the source of shore power, and so we'll get into that later with using a isolation transformer. But before we get to that, a couple cool things the older system had was, besides the separate shore neutral and inverter neutral, was this is the AC ground, the safety ground bus. And all these green wires are what's protecting the individual appliances, the frames of the metal appliances, from electrical shock to humans. So you see this on hot water heaters, on air conditioners. This safety ground is in case there's a fault to the actual frame of the appliance. If you touch it, you don't create a ground between your body. This would send the electrical ground to the boat ground and then back to shore. Before this ground runs all the way to shore, there's this little blue box down here, and this is a galvanic isolator. And so it just feeds from the boat AC ground through this galvanic isolator box, and then through the shore power ground, and this prevents galvanic corrosion between boats while you're connected to the AC shore power, and that can eat away any metal that you have touching salt water. So you're talking your prop shafts, your other appendages. It starts going to corrode a lot faster. We also use zinc anodes, but without this device, if anybody had stray current in the marina, your zinc anodes would get eaten through very quickly, and you're going to start corroding the metal in the salt water. So this device is pretty cool, but we're going to remove it because we're going to install an isolation transformer at the back of the boat right next to the shore power input. So the other really cool thing with our green wire AC safety ground is this bus is also grounded to our DC electrical main bus. And so you see these input wires. We have safety input from ground to the inverter. Then we have from the generator to ground. We have from shore to ground. And then we also have the connection to the main DC negative. Our main DC negative is all the way up under here, close to our battery compartment, so we can have shorter cable runs. So back to the DC side of the house, we already have a pretty robust DC positive bus. And so we're going to try to utilize this as much as possible with a few changes. So this used to be a feed into all of our large DC components. And so the top bar was the hot bar, and then we had fuses to all of our major DC components. This Class T fuse over here would power our bow thruster, and this is one of our main changes, is we had a massive Class T fuse going to a bow thruster disconnect switch just through this bulkhead, and then a 4/0 cable run 25 feet from the center of the boat all the way to the bow. And that's just a massive amount of voltage drop trying to run the power all the way up there. And we saw when our batteries would have low charge over the summer, if you utilize the bow thruster too much without having the, say, the generator on, some of our electronics would flash. And so we're really trying to prevent any damage to our sensitive electronics with having a huge power draw by the bow thruster. So we're going to redesign that in the new design and put some batteries up at the bow that have shorter cable runs and separated from the rest of our electrical system. So then we're going to reuse some of these bus panels to then power our DC 24 volt panel. We're going to power the DC 12 volt panel through a DC charger, and then we're also all going to have some inputs coming in from solar inputs on 2 different buses, and then we'll have a spare for if we had more solar. And so you can see the top side of the bus is the always hot side, and you can see these orange cables with 10 amp fuses were set up for our bilge pumps, which is a good idea to have the bilge pumps able to always be on even if you disconnect the rest of the battery panel. And they're still protected with fuses, but we're going to change this design up a little bit more so we have a more dedicated input bus, and then we have a more dedicated always on section. So we still want to be able to disconnect the majority of the loads on the boat with one switch, but we want to make sure we still have input from solar to our chargers to then charge the bow bank, to charge the engine bank, the house bank, and then also have our bilge pumps on all the time. So we're going to redesign this a little bit, and we're also going to use a Victron link system to have a few more Class T fuses for the incoming batteries, and then handle larger cables for our new inverter multi-pluses. And so we're going to utilize this bus, but we're going to add some more larger buses closer to the new batteries. So one of the biggest decisions with a new power upgrade on a boat is what batteries to use. So lithium-ion batteries are usually the battery of choice these days. They've become very popular, but even within that market, you have to choose what battery is right for your purpose, what battery fits in your individual compartment, and what has the base capability and BMS integration system. So there's all kinds that goes into your battery selection that we'll go into more later. But first we figure out what actually fits inside of our boat. So this is our old battery compartment, and I've already removed a lot of our batteries. Our old design was 3 strings of 4 batteries. So these are 6-volt AGM batteries, and so we had 4 across in each column, and then we had 3 going across. And so 4 batteries at 6 volt connected together made our 24 volt system, and then we had 3 of those strings to increase our amp hour capacity. So removing all of those batteries, we now have to figure out what can we actually fit inside of the boat. Do we need to rebuild any mounts or anything? So my first measurement was what fits in the existing opening, and then what fits in the existing mounts that we already have, and can we find batteries that already fit here, and if not, then what kind of modifications do we have to do? So luckily we found that the Victron lithium-ion next generation batteries do fit inside this compartment, and so we're going to be able to set up our batteries, they're longer, but they'll be at 24 volts. And so we're gonna set up 4 Victron batteries inside this compartment, each inside the old slot. And then they're gonna be long, almost the length of 2 of our old batteries. And then we're gonna have a little bit of space on this forward bulkhead to connect the distributors and the BMS before we reach the rest of our system. So, looks a little bit messy, and all these wires and cables have already been disconnected. So once it's all tidied up, we'll have everything bundled back up. And then we also have ventilation coming in and out of this compartment the way it was designed. It runs through a tube up forward of the boat, so it has some ventilation. And lastly, this is the inside of our electrical cabinet. So once we design our whole system and figure out what components we want, now we have to actually find out how does it fit inside the boat. So these are the constraints we're working with. This is where our old charger and inverter used to mount, and the newer ones are going to be slightly larger. So very fine-tuned measurements to figure out where does everything fit. Then we'll mock it up and go from there. So we're going to have our major brain and power system of the 2 inverters will be inside this cabinet, and then along this wall I'm going to build a false wall right here that we can then front mount all of the solar charger MPPTs, the DC-DC chargers for the 12 volt panels, and so on. So this is where all the magic's going to happen. Where I'm standing right now is where our refrigerator will go. So this whole area will get closed back in. And underneath us is our water tank project that we did. And then on top of the water tank project is another false floor where the AC compressors for the refrigerators stay. So stay tuned for our next video where we'll dive into the actual wire diagram and selection of what components we're going to go into. See you next time. Good morning, everyone.
It's the afternoon.
Who cares?
That's so weird. If you're not like live streaming or something.